Hello, my name is Yuxuan Zhang. This is my second project, Simacogo, for the CSC480 class, and welcome to my website. So here I'm going to give you a quick demo to show you how to play this game. Alright, firstly you see this user interface, and then here it gives you this symbol of each player, and you can adjust the difficulty of the game. Alright, let's just go with the medium and let's play. I'm just trying to maximize my score here. I can always change the difficulty of the game. And if I switch to hard, it's going to take longer time. But I feel like several seconds is okay. Hopefully, okay, 6 seconds. Alright, now you get the idea. So let's go to the code part. How is this game modeled? Well, the board of the game is represented by this 9x9 two-dimensional array. And then for each action, you choose a specific column to drop the checker. To calculate the score, you get two scores for every neighbor that's in the horizontal and vertical positions, and you get one score for all the neighbors in the diagonal and reverse diagonal positions. So how is this Minimax algorithm working? Here, each state is represented by a node. We have the attribute that includes the board of the game, the action that human made, the depth that agent is going to look further down the tree, and who is actually initiating this move. And then we're going to define alpha and beta, which characterizes the bet score for both agent and human respectively. Once we have that, we're going to call this minimax function recursively to search down the tree. And here is a quick illustration to show you this process. So when you came here, so this agent explores all possible moves, like all the columns, and finally it decided to move here is the best way to go according to this certain depth. Alright, back to the code. We have this class node with all these familiar attributes. I just want to show you this minimax function real quick. So let's say a human player just made his move, and now is the agent turn to make his move. When it first came here, it's going to check if it is the leaf node. If not, then move on. If it is the leaf node, it's going to return the score of this node. So this is an agent move. It's going to explore all possible columns, and then for each column, it's going to create a child. For this child, it's going to call the minimax function again to return the score of that child. If the score is better than the agent score, the agent bet score is going to be stored as the bet score. And for the pruning part here, if the bet score of the agent is better than the human's bet score, which played as the main, we're just going to ignore this node, because there's no way that human player will allow us to make this good move. And lastly, we're going to update this bet score for agent. So basically the same thing for human, except that we're using different checkers and compare it with the agent bet score. So now I want to talk a little bit about the heuristic function. So here, the bet move is made based on two things. One is how much advantage the agent could gain after this move, and the other part is the the disadvantage the agent could avoid by making this move. So specifically, a score of the move is composed of how much score of the board the agent could gain, how much score that agent could block the human player, and we're going to minus the human's move, the human's score, if human takes advantage of this action. All right, that's basically it. Thank you.